Okay, folks, so having successfully calculated our standard deviation, we are now going to calculate the interquartile range. Okay, so the interquartile range is, again, just to go back to our image here, is basically kind of, these are basically the boundaries of what we would consider or think about as extremity when we are using the median to evaluate a data set. So on a skewed data set or a not standard distribution, we would look at the upper bound and the lower bound. So the lower bound is on the Q1 side, if the values are smaller. The upper bound is on the Q3 side, the values are larger. And as you can see, it's a very simple calculation here. It is going to be the Q3 value plus 1.5 times something called the IQR. Okay, same on both sides. We're going to use this IQR, the interquartile range. And what is that? The interquartile range is simply the difference between Q3 and Q1. Okay, so again, anytime we hear the word difference, we know we mean subtraction. So IQR is very simple to calculate because it's just Q3 minus Q1, 490 for us. And now our upper bound, right, is just going to be Q3. So again, I'm going to do equal signs. So I'm going to say, okay, I want the values in Q3. And then I want to add to it, I'm going to put it in parentheses just to be certain, 1.5 times the IQR. Okay? And the lower bound is going to be similarly calculated. I'm going to use the IQR, but I'm going to say this, this is the lower bound, so I'm going to start I'm going to start with the lower value, and I'm going to subtract 1.5 times the IQR, and I get negative 375. So as I mentioned in class, sometimes we get values for this that don't make sense with in light of the actual thing that we're measuring, right? So a negative 375 second ride doesn't make any sense in the context of city bike or any other kind of bike ride, or just in time in general. But that's okay, right? Because again, what this gives us is we now have an upper bound, 1585, which lets us know, for example, that like although 1410 looks like a lot, right? That upper bound only gets crossed for this last handful of values, right? So again, what we're interested in knowing is where's the middle, how spread out is this data, and how can we start to think about, and how does that let us start to think about what values might be truly extreme or typical. So we have one final step here, and that is that we're going to calculate something called the standard score. Okay, standard score. And the standard score is actually quite simple. Again, it's one of those things that might seem a little complicated at first, but basically the standard score is just how many standard deviations away from the mean is this particular value. Okay, so there's one standard score for every value, and basically what you're doing is you're treating the standard deviation, which for us is that 600 something, 612, 613. We're treating that as a unit, and we're saying how many of those units away from the mean is this particular value. So again, it's a pretty simple thing to calculate. We're basically just, all we're going to do is we're going to first say, actually we already have the difference from the mean, so we don't even have to do that, right? We already know the numerical value. We just have to say, look, this is the difference from the mean divided by the value of our standard deviation, right? And in this case, again, I have a formula. I am going to fix that one reference where I'm referencing the standard deviation in this case, so it doesn't start to move down on the right-hand side there. And so I can just copy and paste this down. And now I have the standard scores for all of the values in my data set. So again, what does this tell me? Well, interestingly, there aren't really, if we look at the standard score, there aren't really any values that are super extreme here. I don't have a single value that is over 3. And usually 3 is kind of our cutoff point. We kind of think of like, okay, if it's more than 3, then it's a lot, or then it's pretty unusual. But if it's not more than 3, then it's probably fine, or it's probably like not that unusual, right? Again, the thresholds that we're looking for here, this is simply we're simply looking at this in a statistical context, right? Now, none of this means that we need to be looking for things that are statistical outliers in order to do stories on them, right? Because there may be other cutoffs that we're interested in. So what this does is it gives us a sense of the data set unto itself. But for example, if there was, one of the things we might look for in city bike data, for example, let me just very quickly do, how long is the free ride for city bike? My recollection, although I don't have city bike, is that, okay, you get unlimited 30-minute rides in a 24-hour period, okay? So you get up to 30 minutes free. Annual membership, unlimited 45-minute rides. So one thing we might look for, right, is we might see if all of the rides are staying under a certain amount of time, right? In other words, do we notice that people are trying to, just stay under that 30-minute limit? Let's just try that out and say, let's see, what's this divided by 60? Nope, that's 40 minutes. So we notice that there is, there does seem to be kind of a hard cutoff here, right? So we notice that, let's see, 860 divided by 60, I can't do this in my head, it's about 15 minutes. And then the next highest one is 23 and a half. And then we sort of edge up, and then, we get to some of these that are a bit higher. So that's the kind of pattern that we might look for, right? Does it seem like people are being sure to drop their bikes off like right before they hit the 30 or 45-minute limit? In a lot of cases, what we'll find is we're going to find policy issues. So we're going to find that there's a rule or a regulation. Maybe a politician makes a claim about a certain rate of thing, or they make a promise about how how frequent something is going to be, or how much something is going to cost, et cetera, et cetera. Those are the places that we look for as journalists, right? Because that's the benchmark that we're usually applying, is things that matter to people, right? We're not doing this for the sake of the math, and we're certainly not doing it for the sake of the data set. We are doing it because data represents things about people and the world that have impact on people. So anyhow, that is all. That's our measures of central tendency and spread, and how we can use them a little bit to say, oh, okay, maybe these values are pretty unusual. You may notice here that the mean and the median are actually pretty far apart. And though this is not a perfect system by any means, when they're pretty far apart, usually the median is a bit more representative. In a perfectly normal data set, in a standard distribution, in true standard distribution, they'll be in the same place, right? They'll fall right on top of each other. This is a pretty big difference, and we can kind of see, we might sort of eyeball this in the data. Also, when we tried to look at how much of our data was within one standard deviation mean, it was a bit more than we expected. It's closer to 80% instead of 70%. So all of those are clues that this is probably not normally distributed. We will look next week at some strategies for kind of testing whether something is normally distributed or not. But in most cases, what we're going to find is that by looking at both of these things, we get a sense of what's unusual and what's not. So anyhow, that is all for now. We're going to give you some guidance on pivot tables and other exciting things you can do in Excel. Hope you all have a great weekend.